Yeah. Cache memory is the memory which comes in between the processor and the main memory. I had told in previous class that any program to be executed, any instruction or data to be used in the processor must be in the primary memory, that is RAM, main memory. Okay, and now the time taken to access the data from main memory is much more when compared to data time taken from for accessing the data from cache memory. You know that cache memory, the static DRAM is used in cache memory, where the charges are stored, the values are stored already. Okay, and whereas in primary memory, the dynamic RAM is used. In cache memory, static RAM is used. In primary memory, DRAM is used. And in DRAM, the capacitors are used and it discharges. Okay, the charge gets leaked, and then it has to be, by keeping a threshold, the charges has to be increased so that it is we are able to find, the system is able to find what is the charge on it, whether it is 1 or 0. Okay, so however, cache memory is faster when compared to primary memory. Okay, so we use cache memory to access few instructions which the processor assumes is will be the instructions which will be executed next. Okay, so as the speed of cache memory is more, the instructions which the processor assumes, the operating system assumes, which will be executed next, is stored in the cache memory. And also the instructions which are executed recently, okay, data which is used recently, are all stored in the cache memory. Okay, speed of main memory cannot be increased beyond a certain limit. Yes. Now when we say about the hard disk. Okay, so when I say about the hard disk takes some milliseconds to take the data. You had seen the hard disk in a particular video. It is a disk, okay, in which there is a read write head. So this read write head has to move to different tracks of this particular disk, okay, magnetic disk, so that data can be read from that particular track. Okay, so a read write head movement, so that much time is taken when compared to secondary memory, and hence the data is copied to primary memory. Now primary memory is also slower when compared to cache memory, hence cache memories are used. Okay, so that the execution is faster. Okay, the system throughput is increased. Okay, now cache memory is based on the works on the property of locality of reference. Okay, means the analysis of programs shows that most of the execution time is spent in executing few instructions or routines. Okay, that is, if suppose a program is there in which I'll take a small program which there is a for loop. Okay, in which there is a for loop. So you know that these instructions are executed repeatedly for some 10 times. Okay, so those instructions will be stored in the cache memory, and the variables which is used will also be stored in the cache memory. Okay, so the instruction which is being executed now and the nearby instructions, or the processor, the operating system checks which are the instructions which will be executed repeatedly. Okay, and those instructions are stored in cache memory. Now initially the cache memory is empty. Okay, RAM is also empty. Now I access one particular instruction, so that words, okay, that block of words of the primary memory is copied to cache memory, and the the instructions are executed. Okay, so all the nearby instructions are also copied to the cache memory. Fine. So yes, So locality of reference, we can say that yes, the few instructions are copied so that it can be a loop or a nested loop, a few procedures which is repeatedly called. Okay, so those are put in the cache memory. Also the data variables which are repeatedly used are stored in the cache memory. Okay, cache memory can be, the reference can be done of temporal type or spatial, depending on spatial locality. That is, instructions which are recently executed, okay, recently executed are stored in the cache memory, or the instructions which are spatial locality means the instructions which are close to or nearby the currently executing instructions are stored in the cache memory. Okay, usually the instructions which is nearby will be the instructions which are executed next. Okay, if it is a sequence of instructions, so the whole block of memory will be copied to the cache memory also. Now, okay, this is the diagram. You can see that the cache memory is nearer to the processor when compared to the main memory. This is main memory, RAM. Okay, and from whenever the processors request, a processor wants to execute an instruction. Suppose F1 instruction it wants to execute, it wants to fetch the instruction. Okay, F1, you know the process. What are the steps in the execution of an instruction? Fetch the data to the processor, decode the data, decode the instruction, means the processor understands what that instruction must do, okay, and then execute and store the results. Okay, those are the steps in the execution of an instruction. So processor sends the fetch instruction step first. So when it wants to fetch an instruction, it checks in the cache memory because it is faster. It checks in the cache memory if that instruction is there. If the instruction is available, suppose F1 is available, it transfers this particular instruction, that word of instruction, to the processor. If suppose that instruction is not present, okay, then from the main memory the instruction is taken, and the block of main memory, that is which contains number of words, a block of main memory is moved to the cache. Why a block of main memory is moved? Because after execution of F1, usually it is F2, the next instruction which is executed. Okay, so a block of memory which contains number of words are moved to the cache memory, and from here it is moved to the processor. Okay, so F1 instruction is here, which is moved to the cache memory, and then it is moved to the moved to the processor. Fine. So what I am trying to tell here is, any instruction which has to be accessed by the processor, the operating system first checks in the cache memory whether it is there in the cache memory. If it is not there, then it checks the main memory. If it is not there in main memory, then it checks the secondary memory, hard disk. Okay, if it is not there in that also, that means that file is invalid, or that instruction is invalid, it is not at all stored. Okay, any doubt, students? You have understood what is cache? It is nothing but near the processor there is one more chip like the processor. Okay, small. Some caches, as you know, it was told in previous class, it can be embedded within the processor also. Okay, this is such cache is called L1 cache, and this is L2 cache. This will be very less data. Okay, now cache is I say that cache is faster than the main memory. Then why not use a larger cache? Okay, remember in cache memory, the designers are using SRAM, which is costlier, which is bulk. Okay, means to store small 1 bit of data also much space is required when compared to DRAMs. Okay, and it is costlier also. So if we use more cache and more main memory, the cost of the system increases. Okay, so the cache memory which is used is less is very is less space, and so that small amount of data which is repeatedly executed, okay, that instructions can be stored in cache memory. Okay, two types of references. It can be temporal reference or it can be a spatial locality of reference. Temporal locality of reference means recently executed instructions are stored in the cache memory, which is most recently executed such instructions. Spatial locality of reference means the instructions which are close by currently executing instruction is placed in the cache memory. Okay, cache memory executes we are able to take the data from the cache memory with the speed of the processor. Okay, means processor executes in nanoseconds, and accessing of data from the cache memory is also in nanoseconds. Okay, so that is the advantage of cache memory. Any doubts, students? Any doubts with respect to cache memory? No doubts? Listening? Okay. Can anyone tell me what is spatial locality of reference? Can anyone tell me what is spatial locality of reference? Spatial means within that space, nearby. Okay. What is spatial locality of reference? Okay. Once again. So these are the two ways in which the decision is taken, how the data, what type of data has to be stored in cache. Okay, it can be temporal locality or it can be on spatial locality of reference. Spatial locality of reference means the instructions which are close to the currently executing instructions, okay, currently executing instruction are placed in the cache memory. If I'm using the data instruction F1, all the nearby instructions F2, F3, all the nearby instructions are moved to the cache memory. That is spatial locality of reference. Another way of storing the data in cache memory is the functions or loops which is repeatedly executed. So such instructions are stored in cache permanently. Okay, that is temporal locality of reference, recently executed and frequently executed instructions. Okay. So what is spatial locality of reference? The instructions which are close to the currently executing instruction are placed in the cache memory. Okay, what is that called as? Okay, tell me, where is cache memory placed? It is placed in between processor and main memory or between main memory and secondary memory. Where is cache memory placed?
Processor and main memory.
It is between processor and main memory. The speed of the accessing of data from which memory is faster? Primary memory, secondary memory, or cache memory? From which memory faster data can be accessed faster?
Cache memory.
Cache memory. Okay, and how the data is stored means what type of data is stored in cache memory, what type of data or instructions are stored in cache memory. Okay, two ways the data can be stored, that is recently executed instructions. Okay, all the recently executed instructions and repeatedly executed instructions are stored in cache memory. The other way is all the instructions which are nearby currently executing instruction, it need not be recently executed. Okay, all the instructions which are nearby the currently executing instruction are copied to cache memory. Okay, so that is two ways. Only recently executed instructions in cache memory, that is one way, temporal locality. Okay, other way is spatial locality of reference, means all the instructions which are nearby the currently executing instruction. Andre memory in the on the word access ಮಾಡುವಾಗ the complete block means a number of words consist of one block. Okay, so complete block is taken to the cache memory. Okay, that is spatial locality of reference. Now, when I say memory, you know that there is something called as word length. Okay, this is one word. Suppose I say 32-bit memory. It is the 32-bit is one word, and we say that as word length. It contains number of bytes. Okay, this is one word. Fine. So number of words like this forms a block. Okay, and this one block of memory will be taken to cache memory. Suppose I'm accessing this instruction which is there in this particular byte. Okay, the second byte here in the first word. So a block of memory, depending on the architecture of the memory, we will see how the mapping is done. Okay, so a block of data is taken to the cache memory. Right, in spatial, as per spatial locality of reference. Okay, locality of reference means the instructions which are recently executed. Okay, or which are the processor assumes, operating system assumes will be executed next. So such instructions, when I'm referring a particular instruction, the instructions which are near to it. Okay, and recently executed instructions are copied to cache memory. Okay, so next, as I had told you, when there is a read process, when there is a read request to the processor first checks in the cache memory, and if the data is there, if the instruction is there, it is sent to the processor. If the instruction is not there, block of words are transferred from the main memory to the cache memory, and then from the cache memory to the processor. Okay, whenever there is a read request. Fine. Suppose this is block 2. Okay, this is block 2. Cache and primary memory also will be empty initially. This is the processor. Okay, cache memory also will be empty initially. Processor wants to execute the instruction F1, which is here. It checks in cache. It is not there. So it checks in, takes the instruction from primary memory, which if it is not there, it takes from secondary memory. Okay, now if it is there, we assume that it is there. So F1 is taken, and along with it, the complete block F2, F3, all these instructions are copied to cache memory. Okay, now after executing F1, suppose processor wants to read the data F2. F2 is already there, so it is directly taken from the cache memory. Faster access. Subsequent references of data in that block is found in cache memory itself. Okay, so once read request is issued by the processor, it checks in the cache memory first. If the data or the instruction is not present in cache memory, it takes the data from the primary memory which is little slow, and block of data is passed through the cache. Okay, block of data is moved to the cache, and then from cache, word by word, the data are moved to the processor. Okay, so that is a read process, just a flowchart which represents the content, whatever I had told. This is just for your understanding. I put this flowchart. It is not there in the textbook or anything. So the processor wants to receive the instruction which is present in the address array. Okay, so check whether the content, the instruction of array is block containing array present in cache memory. If yes, fetch the data from the address array and give it to the processor. If it is not present, access, if the data is not present in cache, access main memory for finding the address array, allocate a cache block where the main memory content can be copied to the cache block. Simply just to any block, the data cannot be copied, because further references, further instructions also must match to the cache. Okay, so it must be allocated to a particular location in cache. Fine, cache memory is free. I simply cannot put block 2 of main memory to some location. Okay, there is some method in which the selection of cache memory is done. So allocate cache line for main memory, so this particular block must be allocated, and then load the memory to cache and then move to the processor. Okay, so this is a simple procedure. This is just for understanding what I have put. Fine. Any doubt, students? So this is about processor read. Now suppose processor wants to write the data also. If the block is present wherever the processor wants to write the data, to whichever address. Okay, so processor, when it wants to write something, the data will be put in the MDR, memory address register, and address will be there. Yav address access ಮಾಡಬೇಕು, that address will be there in memory address register, isn't it? So address and data will be sent if suppose processor wants to write the data. So yav block al baribeku, that address is mentioned here. Check whether that address, that block of data is present in cache. Okay, if it is present, the data is written. Okay, if it is not present, again from the memory, that block of data is accessed to cache and it is updated in cache memory. Okay, we'll see the procedures, how the data is written, different ways in which the data is written. Okay, now this is about the cache read request. Fine. We'll see what is cache hit and cache miss. Okay, before going to that, any doubt? Any doubt with respect to this? The process of reading the data, or what happens when a read instruction or fetch data instruction is sent from the processor to the memory? Any doubt? Any doubt, students? Okay, now suppose processor wants to read a data from a particular memory location. Okay, where does it search first? Processor wants to read an instruction from a particular word address, memory address. Okay, from where does it search for that instruction first? In which memory?
Cache memory, ma'am.
It searches in the cache memory. If that instruction is there, the data is taken. If the instruction is not there, search in primary memory. Okay, shall we proceed? Any doubt? So I think this also is clear. Subsequent references to the same block is found in cache memory because the whole block is put to the cache memory. Okay. This is just a diagram. Now, cache hit. What is meant by cache hit? Yes, I'll just explain it. Then we'll see what is written there. So, this is cache memory, and this is the main memory, RAM. So, suppose data is requested, F1 instruction is requested by the processor. Processor wants to execute F1 instruction, which is not here now. Okay, so it wants to fetch the instruction from the main memory. So first check whether it is in cache memory. The instruction is not there in cache memory. If that particular instruction is not there in the cache memory, if the data required is not there in cache memory, it is called as cache miss. Okay, cache miss means that data is not there. Okay, so if it is a cache miss, data has to be taken from the primary memory. The block of data B2 is copied to the cache memory. So B2 is copied here, okay, in which F1 instruction is there. Fine, that block is copied to cache memory. Now F1 instruction is sent to the processor and processor executes. So along with that, all the next instruction, F2, F3, everything is copied to the cache memory. Okay. Now suppose processor request for F2 instruction. Is F2 instruction present in cache memory now? Is F2 instruction present in cache memory? Processor request for F2 instruction, which it wants to execute next. Is the F2 instruction present in cache memory? Yes, students. Is the F2 instruction present in cache memory? Yes or no? Anyone can answer. Okay, answer to this question first. When processor wants a particular instruction, only one instruction it needs. Okay, so that is not there in the cache memory. So only one instruction is copied to cache memory, or the whole block is copied to cache memory. Only one instruction is copied to cache memory from the primary memory, or the whole block of data is copied from the cache primary memory to cache memory. Which is correct? Students, are you there? Are you there? Am I audible? Am I audible? Yes, students, am I audible?
Yes, ma'am.
Okay. Others, am I audible? Listening? I am audible to only one person. Students, am I connected? Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. Others? Three people have answered now. Others, am I audible?
Yes, ma'am.
Okay. Answer to this question. When I copy, Suppose the processor wants to read an instruction. Okay, that instruction is not there in cache memory. So from which memory the data will be accessed? From which memory, if the instruction is not present in cache memory? From which memory data instruction is accessed to the cache memory?
Main memory, ma'am.
From the main memory, data is, or the instruction is accessed to the cache memory. Okay, only that instruction is accessed, or a block of instructions? The complete block of instruction is
Complete block of
accessed to the cache
instruction.
memory.
Complete block.
Complete block of instruction is accessed to the cache memory. Okay, correct. So I was explaining about the cache hit. Okay, cache hit or cache and cache miss. Okay, so cache hit means the required instruction or data is present in the cache memory. So such a process, that is when the processor is searching for an instruction and it is available in cache memory, then it is called as a cache hit. Okay, instruction or data is available, it is called as cache hit. If the instruction or data is not present in cache memory, then it is called as cache miss. Okay, it is not available, then it is called as cache miss. Fine. So remember these two words: cache hit, availability of data in cache memory; cache miss, non-availability. Data is not available in cache memory. Okay, that is cache miss. Fine. So what happens when there is cache hit? Cache hit means what? What is cache hit? The processor
Data is
is
available.
requesting for data for an address location, either to write or to read the instruction from that particular location. Okay, the processor may need to write some data to a particular location in memory, or it may need to read the data from the memory or the cache memory. Okay, whether it is for writing or reading, if the data is present in cache memory, it is called as what? It is called as, if the data is present in cache memory, it is called as cache hit. Okay, now so what happens if it is a cache hit and I want to read the data? Okay, read the data. Data is available in cache memory, so data is taken from the cache memory. It can be data or instruction. Okay, it can be data or instruction. It is taken from the cache memory. Fine. Now what happens when there is cache write hit? Okay, I want to write the data to the cache memory. Yes, when I want to write the data to the cache memory, again data is there, ABC, and it has to be returned to a particular block, ABC, to a particular address in cache memory. It can be written. Okay, now in writing process, there are different ways how the data is written. Okay, so there are two procedures. One is called as write through protocol. Okay, write through protocol, and the other is write back or copy back protocol. Okay, write through protocol means, suppose, yeah, it's okay. Okay, so observe here, this is processor, this is cache memory, and this is the primary memory. Okay, now there is some block of data which is copied from primary memory. Suppose ABC is the data. ABC is there in cache memory also. Okay, processor wants to update the data. Processor wants to has copied this block and it is changing something. It is writing into the primary memory. It wants to write D into the primary memory. That is a particular location. So that location is present in cache. So it is a cache hit. I want to access this block in from the memory, and it is present in cache memory. It is a cache hit. Now, the processor wants to write D to the particular block. When it wants to write D to a particular block, it can write D here and also update the same to the primary memory at the same time. So one is at same time it writes in the cache memory and in the primary memory also. Okay, this is called as write through protocol. Okay, this is called as write through protocol. Cache memory and memory location, primary memory location, are updated simultaneously at the same time. So this is write through protocol. Okay, another procedure is I can write the data to the cache memory. Okay, write through protocol. What is the disadvantages? Oh shit. Write through protocol. What is the disadvantages? Whenever I update, so A, B, C, D, it has to be in primary memory also. A, B, C, D. D is updated. And I want to update E. E is also updated. F. F is also updated. So many times this writing procedure is required. Okay, many times it has to be written back. This is write through protocol. Okay, write through. One more method is called as write back or copy back protocol. Write back. So what happens in this is, suppose okay, ABC is there. ABC is there. Okay, fine. So ABC, that particular block is there. Processor wants to write D, so it writes D, but it is not updated. What happens? One bit, it is a particular bit called as dirty bit is set to 1. Okay, or modify bit is set to 1. 1 means in this particular block, a bit position is reserved, called as the modify bit or the dirty bit. In that bit is set to 1. What 1 means, the data, that particular block data is modified and it is not the same in primary memory. In primary memory, this D is not copied. Okay. Now, processor wants to suppose write E to this block. So E is written. Again, dirty bit is 1 only. Means it is modified data what is present in cache. Updated data what is present in cache. It is not returned immediately to the primary memory. This is second method, write back protocol or copy back protocol. Okay. After all modification, I add F, I add G. After all modification, I save the content. Okay. And suppose again, after some time, I do again some changes. I add H, I, and all. So it keeps updating. Still now the primary memory is not updated. Okay, but the modify bit is set to 1. Whenever there is no space in this cache memory, okay, some other programs will be running and its instruction will also be copied to the cache memory. Not only this current programs, correct? So at a particular time, when there is a replacement or which happens, okay, after some time, that is, this whole data is updated in the primary memory. Okay, after updation, the bit is set to 0. Modify bit is set to 0. Modify bit is 0 means data no modification agilla. Whenever there is a modification which is happening, modify bit is set to 1. Okay, modify bit is set to 1 means data is modified. Okay, so if the cache, when if in cache block, if modify bit is set to 1, that means this complete block has to be updated to primary memory. Okay, so these are the two protocols. In writing, when there is a write hit, okay, first of all, main two terms, that is cache hit and cache miss. Cache hit means the required data is present in cache. Okay. Cache miss means the required data or instruction, okay, is not present in cache memory. Okay. So cache hit bandaga, cache hit, the required data or instruction is present in cache memory. So the data might be required for reading process or writing process. Okay, this block of data which is in cache, processor can read some instruction from this block, or it can write some instruction to this block. Okay, is it time? I think it's not time. Fine, well, I'll finish this. Okay, so if the processor wants to read the data, it can read as usual, no changes. If it wants to write, update the data is initially copied from primary memory, correct? ABC only is there. When it wants to update, two processes can be done. Okay, write through protocol means whenever I'm updating, simultaneously update the primary memory also. Disadvantage, many times the updation has to happen in primary memory, wastage of time of the processor. Okay, and system slows means throughput slows. Okay, another method of handling this write hit is, write hit means write operation has to be done and the block is present in cache memory. Okay, so whenever there is some modification in the block, set the modify bit to 1. So modify bit is set to 1, that means data is modified, or the data of this block is modified, and it is not the same in primary memory. So after all the modifications, bit is already, when first modification itself, modify bit is 1. So whenever modify bit is 1, the data has to be updated in primary memory also. Okay, again, okay, in secondary memory, this from data is copied from the secondary memory, correct, to the primary memory. Data is copied from the secondary memory. Again, data has to be updated to this secondary memory also. Okay, so this is not of your concern. So what you should know is, when there is cache write hit, okay, so two protocols can be used. Any one of these protocols will be used, not both at the same time in the same operating system. Okay, so what operating system does? Any one protocol is used. So write through protocol, simultaneously data is updated in primary memory, or write back. Write back means modify bit is set to 1. Whenever there is changes in the block, modify bit is set to 1. If modify bit is set to 1, then finally when the block is, okay, when the block is not required, when it has to be deleted or removed from the cache, if modify bit is set to 1, then this block is updated to primary memory. If modify bit is not set, then it is not, there is no need to update to the primary memory. Okay, fine. That is cache hit. Any doubts, students? Any doubt? Yes, we'll stop there with cache hit. So before closing, I just want to know if there is any doubt. Yes, there must be doubts. Listening? Any doubts? All of you are listening? Suman Kumar. I don't want to call out the names, but you are not at all responding. Suman Kumar is there?
Yes, ma'am.
Okay, good. Suman Kumar, can you tell me what is cache memory?
And it is used to store the processed data.
Used to store the
Processed data.
processed data means.
Like next time if we load the same data, it won't take time to load.
Okay, so instructions or data, okay, that is variables which has to be executed is copied to cache memory. Fine. Next time andre block of data is copied to the cache memory from primary memory. Okay, and next time when you're accessing for that same instruction, it need not be copied to cache memory. That is correct. Okay, good. Can you tell me what is cache hit? Suman? Can you tell me what is cache hit? What is cache hit? Suman is available?
Yes, ma'am.
Yeah, can you tell me what is cache hit?
No, ma'am.
Okay. But previous, I think 15 minutes, I was telling about cache hit. Huh? That means you are not listening. Listen to the classes. Exams will be there. Or if you want to read of your own, you can always do that. And also share the knowledge, whatever you have learned. Okay. Students, anything extra you want to tell, you can always tell that. Okay, if you have learned of your own and you want to tell something extra than what I have explained, you can always do that. Fine. You can message me or tell me in the class. I'll allocate time for you when you can explain that. You can just share the knowledge what you have. It is always good. Okay. Yeah, listen to the class. Listen, be there in the class for the whole time. Okay. Anyone can tell me what is cache hit? Cache hit.
The required data is present in the cache memory, ma'am.
Yes, the required data or instruction, okay, is present in the cache memory, that is called as cache hit. If the data or instruction is not present, the data or instruction required by the processor is not present in cache memory, then it is called as cache miss. Fine. So we'll stop the class for today. Monday you will not have classes, and if any subject teachers wants to take, they can always take, as it is online. Yeah, as per the government's decision. Fine, I'll just stop recording. As per the Karnataka government's decision, you will have the